Good afternoon. I'm going to work on the problem set for 6-1 and 2 law of sines and cosines. Start with the exercises. I don't have the problems on the screen, but I trust that you do have them on your end, so hopefully that's not an issue. So first question has us solving for c using the law of sines. So I'm going to draw the triangle CAB. Okay, so to do law of sines, I'm going to write sine of angle C over side C is equal to sine of angle B over side B. And I chose B specifically because I already know both the side length and the angle, right? So A would not be helpful for my purposes because I know neither of them. So I'm just going to plug stuff in here. Sine of 105 degrees over little c is equal to sine 45 over 20. And then if you solve this equation, you should get c equals 20 sine 105 over sine 45. And then because sine 45 is a quote-unquote nice angle, you are expected to have that simplified. And so this is going to come out to 20 times root 2 sine 105 degrees. Skip some steps there, but I trust that you're able to do that yourself. Okay, make sure it's also rationalized. And then sine 105 you don't need to calculate. Okay, next one. Law of cosines to find angle C. Let's see what I have. CAB 16, 10, and 12. Okay, so to find angle C, right, I'm looking for this angle. So I'm going to want to make sure I use the formula for law of cosines or the particular combinations of sides and angles that actually includes angle C, right? And so that is going to have this as my opposite angle, and so that's going to go on the left side by itself. So I'll have 16 squared equals the two adjacent sides now, so 12 squared plus 10 squared minus 2 times 12 times 10, and then cosine angle C, because that's the angle in between those two adjacent sides. And this is going to come out to, don't really want to do this. Cosine C is equal to 244 minus 256, negative 12. Should be negative 1 over 20. So I'll have angle C is equal to arc cosine of negative 1 over 20. Interestingly, this was the same arc cosine that I did in the video. I didn't realize that. I think in the video it was 5, 6, and 8, wasn't it? I recorded that during 4A. So if you're doing 4A, you might have remembered that. Okay. And of course, if the triangles are similar and the ratios of the sides are the same, you're going to have the same angles. So that's why we got the same answer. Question 3. Solve for A using law of sines. We have this triangle here, CAB, AB 45 here. This is 135 degrees. This is 10 degrees. All right, so I'm looking for side A, which means I do need to know angle A as well, right? So I'm going to try to calculate that angle. That's going to be 35 degrees because all the angles have to add to 180. And so now now I'm going to use the C. I'm going to use these two, and then that will help me calculate A. So sine of 135 degrees, right? I'm going to have to calculate that because that's a nice angle, right? So when we know sine 135 over 45 is equal to sine of 35 over A, which means that A equals 45 sine 35 over sine 135, right? Which is root 2 over 2. And so this is going to come out to 90 over root 2, which is just 45 root 2 sine 35 degrees. That'll be the answer. Okay, then question 4. Solve for A using the law of sines. Have C and A and B. B is 15. A is unknown. C is 30. And this angle is 50 degrees. Okay. So, oh yeah, this is the one there's a typo on, right? It's supposed to say law of cosines, isn't it? We're going to use law of cosines. And we know that we should use law of cosines because we have, right, two sides next to each other with an angle in between them. So that's a good one for law of cosines. So we're going to have a squared equals 15 squared plus 30 squared minus 2 times 30 times 15 times cosine 50. So that's going to be 225 plus 900, which is 1125, I think, minus 900 cosine 50 degrees. So that means A equals the square root of that. Let's do the problems now. Okay, first question. So, we don't have those, we don't have the triangles drawn out anymore, so we have to do them ourselves. Don't forget the important convention where the side lengths have to be opposite the corresponding angles. So I'm just going to draw. Let me try to draw as accurately as possible, just to make this a little helpful. Let's say that's A. Maybe this is C. I think it should be a little shorter, I think. 5.6. Yeah. Okay. I think the angle looks about like that. So this is B. This is 8. This is C5. Okay. And we're given that B is 40 degrees. The thing we're going to want to do here is first probably try to find this side length first, right? Because this is something that we know we should use law of cosines first. And there's really nothing we can do with law of sines. So first we're going to find little b, which is b squared equals 8 squared plus 5 squared minus 2 times 8 times 5 times cosine 40. That's going to give me b equals the square root of 89 minus 80 cosine 40 degrees. Okay. Yeah, I think that's right. Okay, so now I have all 3 sides solved for, okay? Which means that for the remainder, the best way to do this is using law of sines, right? And so we know that sine of angle A over little a, which is 8, is going to equal sine b, which is sine 40 degrees, over little b. I'm not going to write that out because it's very long. And so I'm going to end up with angle A equals 8 equals arc sine of 8 sine 40 degrees over B, which is 89 minus 80 cosine 40. Okay? I will give you a little secret, which is that this answer is actually wrong. The answer in reality is actually pi minus that. The reason being that A is actually an obtuse angle, which is not something that arcsine could ever give us, because arcsine is always bounded between negative pi over 2 and pi over 2. The problem is that is pretty much impossible for you to figure out without a calculator. And so on the, on whatever homework check, I am going to accept this as the final answer, even though theoretically it's wrong. Just because there's always some ambiguity, right? For arcsine, when we have arcsine, we're looking for a point with the y coordinate, right? And it's either going to be here, but it also could be here, right? And so here we have an acute angle. That would give us an acute angle, but here we have an obtuse angle. And both are possible in a triangle. And so it's really impossible for us to know which one unless we have a calculator handy to make sure that the angles match up with what we should expect. So without that in our possession, I will accept this answer with the implied ambiguity. Okay, and then we're going to do side length C. That's the exact same process. Sine C over 5 equals sine 40 over B, which is going to give us angle C equals arc sine of, all right, same answer, just the 8 becomes a 5. Sine 40 over 89 minus 80 cosine 40 degrees. And that means we're done. Let's do question 2. Solve for all the angles and sides of the triangle, and we have three side lengths given. And so for this one, we're just going to use law of cosines for every single angle. I'll show you guys. Say this is 7, this is 11, this is 13. Right, we want to make sure we get the labels right. So 13 is little b, so this should be capital B. 11 is A, so this should be uppercase A. This should be angle C here. Okay, so we're just going to use the law of cosines successively. So 11 squared equals 7 squared. This is for angle A, right? Because 11 is opposite of A. So 11 squared equals 7 squared plus 13 squared. 11, 7, 13 minus 2 times 7 times 13 of cosine angle A. So that means, I don't know if I can do this in my head. 49 plus 169 is 218. 218 minus 121 is 97. So that means cosine A, angle A equals arc cosine of 97 over 182. Should probably check that with the calculator. Okay, next one. We're gonna do, let's do 7. Okay, so we're looking for angle, well, let's do it in order. Angle B. So 13 squared on the opposite side. 13 squared equals 7 squared plus 11 squared minus 2 times 7 times 11, right? Those two adjacent angles times cosine angle B. Okay, and that should give us angle B equals arc cosine of 49 plus 121 is 170. 170 minus 169 is 1. So should have 1 over 154. Okay, so that's our second angle. And then angle C, finally, 7 squared equals, what is it? Equals 11 squared plus 13 squared minus 2 times 11 times 13 cosine angle C, which would give us angle C equals arc cosine 121 plus 169 is 290. 290 minus 49 is 241. So we'll have 241 over 26 times 11, 286. Okay, that's our final answer. So that gives us the other 3 angles that aren't given in the question. Okay, let's do question 3 now. Solve for all the angles and sides of the triangle. Okay, what do we have here? Looks like say this is 35 degrees. B, A, 42 degrees. And that is C, which we can calculate, right? And then little a, so that's this side length, is going to be 12. All right, so angle C, let's calculate that first. 180 minus 42 minus 35 is 103, right? So that's 103 degrees. And then we're just going to use law of sines to find the rest of the angles. So, sorry, the rest of the side lengths, right? And so we're going to get sine 42 degrees over 12 equals sine 103 degrees over C. So that tells us that C equals 12 sine 103 degrees over sine 42 degrees. That's our answer. We also have sine 42 degrees over 12 equals sine 35 degrees over B. So that tells us that B equals 12 sine 35 degrees over sine 42 degrees. So those are our final answers. Question 4. Pretty much the same as what we just did, isn't it? Let's see, 35 and 65, so it'll look more like this. Okay, 65 degrees, 35 degrees, what is that? C is here, A is here, And b is here, and little c equals 10. So this is A, and this is B. And then this angle here we can calculate is going to be 180 minus 35 minus 65, which is 80 degrees. Okay, so now we can use law of sines. So sine 35 over 10 equals sine 65 over A. So A is equal to 10 sine 65 over sine 35. And then we have sine 35 over 10 equals sine 80 over B. So that means B equals 10 sine 80 over sine 35. So that concludes this problem set. Let me know if I have made any typos. I'll give you some extra credit in my heart. And yeah, good luck on the homework check. I do confess that some of these problems are a little easier than the others, so just pray and cross your fingers that you get the easy one. Have a good night.